In this video, I will talk about a special case that occurs when we are solving a triangle, meaning that we're going to find all the sides and all the angles. This case is called the ambiguous case. Now, if you're given the measures of two sides and the contained angle, which we'll call it as side, angle, side, then the triangle is uniquely defined, meaning that there's only one triangle. So this would look something like this. So we have one side, another side, and the angle, which is in between the two sides, that's called the contained angle. We'll only have one triangle. However, if you're given two sides and the angle that is not contained, but it's opposite one of the sides, which we'll call side angle, then the ambiguous case may occur. And this looks something like this. So we have one side, we have another side, and then the angle is over here still. So in the ambiguous case, there are three possible outcomes. Now, in all these situations, we are going to be given, and I'll write this down, we're going to be given an angle A, a side A, which is opposite the angle, and a side B. All right, now the first case is there is no solution. So this occurs because, let's say that I have my angle down here. And so if the angle down here, and then I have a side A over here, and then I'm going to put my side B on this side. So when I take a look at this, if the angle is acute, meaning that it's less than 90, then you can see that this side A, it doesn't quite reach the other side. So if I draw a perpendicular here, a right angle, I can see that sine angle A is equal to, we'll call this the height, h divided by b. So sine angle A is h divided by b. So in this case, our A is less than the height. It's too short and it doesn't reach the other side. So we can also manipulate this equation here to say that sine A times b is equal to h. So then I can now replace h with b times sine A. So if A is less than h, which means it doesn't reach, then there's going to be no solution. Now the other case is when it's obtuse. So we have the acute and the obtuse. So when the angle is obtuse, meaning that it's greater than 90, so here's my angle A. I'm going to have my length A here and my length B here. So this time again, A isn't long enough to reach the other side. So in this case, what's happening is that A is smaller or equal to B. So if A was longer than B, then we would be able to reach, but since it's not, there's no solution. The next possibility is that there is one solution, which is what we normally see. So in this triangle, we can have strictly just the right triangle. So we have our angle A, we have the side A on this side, and we have B over here. So in this case, A is equal to H. And so it reaches the other side, and it's the same as the height. The other case is where we have our angle A, our side A is over here on the other side, and B is over here. And this is where A is greater or equal to B. So since it's greater or equal to, we actually will be able to make it to the other side. All right, so that occurs when A is acute. Now if A is obtuse, this is my side A, this is my side B. If A reaches the other side, then we're going to have one unique triangle. And the reason that it does reach this time is because A is actually greater than B. Now the third possibility is that there are two solutions. Now you might be asking yourself, how does this work? So let's say again that I'm giving you an angle A, and I give you a side A, which is opposite that angle, and a side B. So in this case, we can draw this one triangle that looks like this. However, who's to say that I'm going to draw my triangle exactly like that? Let's say that I know this length here, and I can actually pivot up on this top vertex here. I could actually maybe draw this triangle like this instead and have my A value over here. So what I have is another triangle that has the same angle, the same side length B, but instead of opening out to create more of a wider angle, I'm going to come back in to create a smaller angle up at the top here. And this length A is still the same as the other length A. And then I would have my height in the middle. So what's happening here is that I can see that my height is shorter than A, less than A, but A is also less than B, which can create this two-solution triangle. So there are two solutions because A can create the acute angle B, which I'll place over here. I didn't do it in the other ones. So we can have this acute angle B here, as in the first triangle, or we can have the obtuse angle B as in the second triangle. So over here is where B is. And notice that here I have an obtuse angle, but in the first one, or the first triangle, I have an acute. And this is called the ambiguous case. Now, because of this ambiguity, we should always check for a second triangle. So the second triangle B can be found by subtracting the first angle B from 180 degrees. Now, the reason that we can do that is because knowing that this side length is the same as this, we have an isosceles triangle here. So this angle B should be the same as this angle B as well. So when I want to find this side here, or this angle, which is this here, we know that these two angles add up to 180 degrees. So to find the angle that I've marked in green, I can subtract 180 minus angle B to get the one I've marked in green. So I'm going to say that because of the isosceles triangle that is formed. All right, so let's take a look at an example. First, we're just going to take a look at how to determine whether there is no solution, one solution, or two solutions. So in these questions, you'll notice that the triangle is not drawn for you, and this is something that you have to do yourself. Now, I recommend that the angle that is given be placed in the bottom left. So we're going to place angle A here, which is 28 degrees. And then I'm just going to automatically draw an oblique triangle that looks like this. So this will be 63 centimeters. I'm going to place my B over here as 117 centimeters. So if you want to label this, this can be your angle B, and this top will be angle C. So my height of this triangle will be right here. And if I want to find that height, because I want to compare that height to this side length of 63. So sine 28 degrees is equal to height divided by 117. So my height is 117 times sine 28 degrees. And the height is 54.93. So reasoning this out, I can see that my height is shorter than this hypotenuse, which is good. So I know that there's at least one triangle. However, I also notice that 63 is smaller than the 117, which is the side length B here. So since H is less than A, which is less than B. So I know that there has to be 1 because this height gives me this side length of 63, which is bigger. Then I know that I could probably draw another one over here that is also 63. So therefore, this triangle has 2 solutions. Let's take a look at another example where we actually have to solve the triangle. All right, so in triangle GHI, we have angle G, which is 27 degrees. So I'm going to do the same thing I did above. I'm going to place my angle in the bottom left. So this is 27 degrees. The opposite side is over here, which is 25. And then I'm going to place my other side on the left side here, which is 30. And since this is H, this will be capital H. The top will then be I. All right, so to find H, or the angle H, we can use our sine law. So sine H divided by 30 equals sine 27 divided by 25. Multiply both sides by 30, and I get 30 times sine 27 divided by 25. So to find my angle H, I'm going to multiply 30 times sine 27 divided by 25, and then I need to take the inverse sine of this to find the angle. And this will give me 33.01 degrees. Okay, so now that I know this is 33.01 degrees, I can find angle I. So angle I is equal to 180 minus 27 minus 33.01, because all the angles in the triangle add up to 180. So angle I is going to be 119.99 degrees. All right, so we're on our way. So I have angle I, so now I'm going to find the length I. So the length I is opposite the angle, so I have little I, which is the length, divided by sine 119.99 degrees equals to 25 sine 27 degrees. Isolate I by multiplying by sine 119.99 degrees on both sides of the equation. And this will be divided by sine 27. Type this part into my calculator, and I get 47.69 centimeters. All right, so pausing a little bit here, this is if I drew the triangle like this. But what if I had decided to draw the triangle like this? Would this work as well? So we know that this is also going to be 25. Since this part is 33.01, we have an isosceles triangle, making this to be also 33.01. So what I now need to do is find this new angle H down here. And angle H is equal to 180 minus 33.01 degrees, because these two angles add up to 180. So angle H is 146.99 degrees. So that I don't confuse it with the first angle H, I'm going to put a little prime beside the H to show that this is the second triangle. Now I can find my angle I, similar to how I found it before. I'm going to call this angle I prime. So I get 146, I have 180 minus 27 and minus my 146.99 degrees, and angle I prime is 6.01 degrees. So there seems to be like a triangle that's working here. So this is 6.01. All right, last is to find little I, and we're going to use little I divided by sine 6.01 degrees equals to 25 divided by sine 27 degrees. Isolate my I by multiplying by sine 6.01 on both sides. And I get that little I, the length I, is 5.77 centimeters, which shows me that I actually do indeed have two triangles as solutions for this triangle here.